Now that we have had a little bit of practice with the divisibility and also knowing what it means to be not divisible, let's see if we can show the following statement is false. For all integers a and b, if 3 divides a plus b, then 3 divides a minus b. How can we go about showing the statement is false? First of all, this is a universal. It has a for all in front. So to show that it's false means we need to find a counterexample. We need to find integers a and b where 3 divides the sum of a plus b. But at the same time, we want 3 to not divide a minus b. So all we have to do is to pick random integers. And there are more than one possible solution that may work. So for example, I could pick 1 for a and let's say 2 for b. Then 3 will divide 1 plus 2 because 3 divides 3. However, 3 will not divide 1 minus 2 because 3 does not divide -1, the result. So that would be considered one counterexample, and there's more than one option here. Here's another possible, more formal solution. So the proof consists of first saying that we want to show that the statement is false, so we need to find correct values for a counterexample. In this particular slide, I chose a to be 2 and b to be 4, just to add some variety. We definitely know that the chosen variables a and b are integers because 2 and 4 are themselves integers. Now consider the summation of a plus b, which ends up being 6. And if you subtract a minus b, you end up with -2. It is clear that 6 can be divided by 3 because 6 can be written as 3 times 2. And it's also pretty obvious that 2 cannot be divided by 3 because -2 cannot be written as 3 times some integer. So this shows that 6 can be divided by 3, -2 cannot be divided by 3, which shows that the statement that we were supposed to prove is false. So that pretty much is the end.